Good afternoon.
Good morning, everybody.
Good morning.
Yes.
Wanted to start off with a famous, often credited quote to Henry Ford, which is just like the internet always is pointing out correctness. Not necessarily what he quoted, but it's often credited. If I had asked people what they wanted, they would have said a faster horse. And I think we're in the midst of an AI revolution where we're not talking about incremental changes in the industry. We're talking about a fundamentally new way of working. So with that, welcome to our webinar today. We're going to be discussing the next frontier of productivity. Welcome, Arnold, our CEO, and myself, Bam, the CRO. We're going to share all of the inside details, insider secrets of what we've learned from deploying a massive AI cloud, AI factory in the last year.
Yeah, absolutely. So let's kick it off.
All right. Okay, so as we mentioned, we're in the midst of a revolution. If we look at the business drivers, and it's not always about business, we'll come back to that later, but if we look at the business drivers, AI agents are going to be dramatically enhancing your workforce. The secret to success and the stage where most companies are at now is how do you capitalize on leveraging your corporate data? So everybody's been, utilizing ChatGPT and other AI tools privately, but for AI to be really useful, and we're going to talk about how to best do that safely, we really need to think about how to capitalize and utilize corporate data. But in Europe, we have to think about how to do that in an extremely careful way to stay within the regulations. As everybody knows, Europe is the world leader in regulations, so we have to be sensitive to that. And finally, AI is enabling an entirely new wave of completely autonomous business operations.
Yeah, I think it really shows in the next slide how this will change how we work, right? I think business leaders are starting to see that AI is not just a tool which brings some extra productivity to the workers, enhancing the workforce, but it's also part of workforce itself. So many of today's AI solutions are already capable of doing autonomous business and operations. And with the introduction of agents, that's something that we will see in the next year. This will grow very, very quickly. Yeah. And for those AI agents to work properly, they need to have a connection to your data, to your corporate data, your most sensitive possession mostly, to create context and enhance the models on your specific use case and business operations.
Exactly. Arnold, we often talk about, if you look at all the different departments of an organization, and here being an example of that, AI will eventually be sitting on top of all of these data sets, will enable, natural language query, more advanced utilization of all that data, which is very often underutilized. And eventually these agents will all start communicating with each other and create a kind of holistic approach to understanding the data in your organization and being able to take action on that data. So we see this as the vision in the next few years. And of course, if your company or even yourself don't stay on top of things, there's going to be a tendency to fall behind. But of course, for corporations, that's a life or death struggle. For people, it's just a choice.
Absolutely.
So when we talk about essentially in Europe, with all of our data regulations, connecting data, it's not always as simple perhaps as in other areas. It's important in our case to recommend that we would utilize open source software. And you want to be careful that if we're connecting your data to public systems, and I mean like public cloud and OpenAI, etc., you might be open sourcing your own IP in some kind of shared model if you're not careful. There's ultimately no way to audit that data if you're connecting your corporate data to an API. These are huge challenges. you really don't know. The data kind of goes into a black box. And in Europe, we do have to audit data. We get government requests. If we can't provide a fundamental audit, which would be the case utilizing, remote SaaS systems, that's a challenge for the company in terms of fines and penalties. And I like to credit Arnold by saying this the first time I heard it, which is so true. You can only give away your data once, meaning, there's been famous cases at Samsung and others where, very private IP has been shared in a model on purpose to utilize it, but then with those companies not realizing that data then potentially becomes exposed to the world.
Yes, and good to remember is when you expose your data to a public model, there's no way of getting that information back, right? So if you make a mistake, it's out there forever, right? So it's in the model, it's part of the model, and you can't just say we'll take this part out again. So to really underline this message, you can only give it away once. You can't take it back. So having control over your data and having control over what data goes into a model and owning the model itself, as in using the open source models, is a very, very secure by design approach to using AI.
Right. So it's all about finding the right balance between innovation, which is what we're all looking for to enhance the services, and then balancing that against your particular set of risks. Exactly. Based on what type of company, what type of data you're putting in front of AI, and actually what country and what region you're in. So what are some of this very specific challenges that we have in the EU together with connecting our corporate or our organizational data? This could also, by the way, be patient records. It could be government data. It could be GDPR, PII data. So regulated data is defined. GDPR is one of the main considerations, which is generally considered to be private data within the EU. So GDPR overlaps with data sovereignty in the sense of, the data should be local in Europe. It should be controlled and operated by European companies. And this actually means that, utilizing some of the foreign, let's say, national SaaS companies or private or public clouds may not. And we have lots of conversations with lawyers and legal teams that, in fact, it's very close to impossible to be fully GDPR compliant if you're not working with local providers. The AI Act, which we've all heard about and are attempting to implement in some way or the other, if you're active in a corporation or an organization in Europe, really forces us to be able to be transparent and to be able to audit and provide traceability. And that means that you do need to control your own data, your own models, your own backend databases, if you want to be able to provide that information or be aware. And finally, something that we've been discussing recently internally and with our clients is that according to NIS2 and the latest updates, executives in organizations are actually personally liable for non-compliance. And this was intentionally done to break down the kind of shield of the non-liable corporation and make sure that companies actually operate in a compliant manner.
Yeah.
So we have this, Arnold, we have this conversation with our clients constantly. There's a massive adoption of public cloud, AWS, Azure, Google Cloud in Europe. And, it's a great infrastructure. We know it's not really designed for AI. We're going to, cover that in a second. But Arnold, maybe you had some special insight on the non-compliance of public cloud for GDPR. You want to maybe mention something about that?
Yeah, sure. So that's basically what we said in the previous slide too, right? So if you have regulated data, that could be patient data or financial data, to be fully GDPR compliant, you need to have it in a cloud, which is, if you use a cloud, which is located, controlled, and operated from Europe. And most of the big US hyperscalers mention that they have a location in Europe, but it doesn't mean that it's controlled and operated from Europe. So especially with those data sets, and we have customers in healthcare and in the financial sector that are very stringent about the interpretation of the GDPR, you see that we need to sign documents that we cannot hand over control outside of Europe or locate the data in any way outside of the European boundaries. So yeah, it's especially important for those companies that use that kind of data, regulated data, or high security data, to make sure that they don't have a single cloud strategy, but use a strategy where they have that data on their own on premises in a secure cloud, or well, not share it in with the US hyperscaler in any way, right?
Exactly, and just the legal side of that, which is very interesting, is the U.S. One of the outcomes of the U.S. Patriot Act was the U.S. Cloud Act, and the U.S. Cloud Act literally gives any U.S. agency, so think of the CIA, the FBI, any of the U.S. agencies, access to data hosted in a cloud or a service provider that's American owned and operated anywhere in the world, meaning that any U.S. agency can request data from an American cloud provider with European data sitting on it, which is why we see military, government, finance, hospitals with patient records very often choosing not to use public cloud for certain sets of data. Now, there are two other areas, significant areas, where we see challenges with US-owned or foreign-owned organizations, but in this one in particular, U.S. public cloud is really designed as a commodity infrastructure, and we see that it's not really, or not designed from its core to support the performance, the very high performance requirements of AI workloads. There are certain exceptions to this for maybe very large enterprises engaging with public cloud, but in general, they're kind of putting lower performance GPU cards and servers. The networks are rumbling. They're not really set up. They're not using parallel file systems, all these technical things that open up the data flow and remove the bottlenecks. So we see significant performance challenges, accessibility challenges, availability challenges. And finally, we see that the unpredictable costs around deploying on GPUs and infrastructure in public cloud are frustrating for a lot of organizations. And not to mention, there's been many reports that the costs of GPUs and AI infrastructure in public cloud is generally 2 to 3 times the actual market price versus the neo clouds, which is where we kind of play and have built these very specialized infrastructures.
Yes, absolutely. So we see many startups getting started in public cloud, and then often usually subsidized, right, with a booster package, where they get burn credits,
right? The famous credits
that they get. Yeah, but as soon as they onboard larger customers or scale out, compliance and cost and performance become a real issue. Yeah.
So the conclusion that we've come to after many conversations and customer deployments and everything is it's fine to use public cloud or whatever you have access to. Public cloud has the advantage; it's very easy to consume. So experimenting or playing around with private GPT and utilizing Copilot and Bedrock and all these things for experiments and building prototypes is fine. But there's a real question when it comes to connecting all of your internal regulated data. That's where the question comes in. And so our kind of objective as a company is to solve that challenge for companies, and we're seeing a lot of traction in that area. As soon as you get to how do I connect my user databases and all my different file sets and my archive data and my production data, we get companies and organizations get nervous putting that in the public cloud, as for the reasons mentioned. Arnold, do you want to introduce our private AI stack?
Yeah, sure. So what we've done is we see a lot of customers where we talk to. They want to start out with AI, and they have a general idea of what projects they want to start and what functionality they want to build. but it's really hard to start because you need a certain technology stack, which you can basically use from the internet, like ChatGPT or Copilot. And on the other hand, you need to make sure that that technology is built for yourself in a private manner. So what we've done is created a layered approach to delivering that AI functionality, where we start out with the private GPT. That's basically a SaaS application that you can use from day one, which gives you basically the functionality that you might expect from ChatGPT or Copilot, but then in a private and sovereign way. It's in your own data center. It uses your data, not other one's data. It's not sharing any data. So you stay in control. That's very important. It also has some security features integrated into it, but we get into that later. We move on to the private AI factory, which is an add-on to the GPT, where you can basically build the applications yourself. That's very handy if you have specific processes or functions in your organization that require a more tailored approach. And third, we have the private Neo Cloud. So Neo Cloud is the term for the new generation clouds that you will see getting started. Those clouds are mostly NVIDIA or other GPU vendor-based accelerated. We use NVIDIA, obviously, as a technology stack to build a cloud that's mostly built for AI solutions, but can also host other applications with a strong focus on containerization and Kubernetes. And last, we have our expert engagement. What we see is that it's easy to get a GPU somewhere. It's maybe even easy to get a software package, but then you also need the expertise to build real applications and real outcomes. And that's where we help our customers get to, right? So we have the expertise in-house to make sure that your people can use our technology stack in the right way.
Thank you. Let's dive a little bit into one of the really, we've been getting a lot of really positive feedback and a lot of traction with our private GPT. And so if people within organizations want to use ChatGPT, this is somewhat of a challenge, again, connecting data because it's not sovereign or GDPR compliant. We found a simple alternative to that, moving up in the value chain by providing a fully dedicated private GPT. This means that you don't, as a company, have to consider how to build an AI application, which is where a lot of companies get stuck, but you can just start consuming it as a SaaS. Yes. And all the data is secured, it's GDPR compliant, NIS2 compliant, all built on NVIDIA infrastructure with our using open source models. So this is something that, if you guys are listening in right now and thinking, how do I use ChatGPT within my organization, which is very often getting blocked, we have a solution ready to go where you don't have to build anything, and it's the entry point into AI. The really interesting part here, and I think this is really fascinating, is we've reached an inflection point where we see that NVIDIA's Nemotron, which is an open source LLM, which is actually based on Meta's Llama 7DB, has been specially fine-tuned by NVIDIA. And very interesting is that on the 4 most popular quality benchmarks, you can see here that the Nemotron is outperforming ChatGPT 4o, and that's quite a feat. So everybody likes, most people like ChatGPT 4o, think of it as fairly advanced, but we now have a 7DB model, which is outperforming on ArenaHard, Alpaca Eval, MT Bench, and is providing, extremely excellent responses. So we're basically at an inflection point where open source is starting to exceed the commercial models. This means that we can provide a very high quality solution. So I think that's fascinating to understand. The private AI factory, once you start with private GPT, we can roll out, licenses, people can start using it. And the private AI factory means that now we can start improving that model and customizing it. The first thing that most companies want to do, or organizations, is they want to attach an agentic RAG workflow, or in layman's terms, attach your company data and figure out what's the right workflow in order to access that data, files, databases, etc., emails, could be anything that you want. We can do model training for specific expertise. We can do fine tuning. These are all add-ons that we can add once you start and you want to keep improving those models. How does NVIDIA help here? And this is a really important piece for us. NVIDIA's non-proprietary software model means that, through AI Enterprise, we have access with you to 1,500 open source frameworks, tools, and libraries, stuff like PyTorch, TensorFlow, Triton Server, TensorRT. If you're technical, then you recognize all of these things, as well as a bunch of pre-trained models and all the different types of things you might need to improve those models and customize them for your environment. The basis of all this, again, is open source, and this means that we can import open source models into your private environment or into our private cloud, and that we avoid these external APIs and connecting data. Yeah. Maybe Arnold, do you want to take us through the private AI factory in a little bit of detail here?
Yeah, so what you just said, right? So the NVIDIA Enterprise Suite, it's really a big offer. It provides a lot of out-of-the-box solutions for building AI applications, and what a lot of people don't or seem to underestimate is that you can build a AI application on your laptop very quickly. But if you want to scale it out in a data center and make sure that your whole company uses it, and maybe all of your customers, that's really complex to build that. And NVIDIA has made it very, very easy for us by providing integrated modules that have all the moving parts that you need to run those applications. It's part of the AI factory, and basically what it enables you to do is create applications and agents that connect to your corporate data. You can run a multimodal model on top of it. One of the, for instance, Nemotron, that's like Bam just said, the optimized version of the open source Llama model. So Nemotron is an optimized and secure version of that one, and you can use it for text, vision, and audio. And next to it, you will have the more like AI factory features, which are enabling developer mode. So your developers or more tech-savvy business users can develop AI applications themselves and fine-tune those models into a specific knowledge category. So, for instance, have a Nemotron more focused on legal or on finance, marketing, code development. So, and this gives you the opportunity to create those agents connected to your corporate data. So you basically create a AI-based workforce of agents that can help your people be more productive or enable autonomous business operations. Yeah.
Exactly. And then the outcome of that, as you see on the right, is each department may be utilizing different forms of AI. So, for example, marketing may be making visuals and images and writing content. Sales may be using AI to help their outbound, their communication. Finance may be doing kind of analytics and analytical predictions. Dev code, so the engineering department may be using it to assist in their coding. Customer support would be using AI to receive phone calls, right? So you can see that each department utilizes slightly different things, and there are different models that are optimized for that, or it can be in the beginning a kind of shared model.
Exactly.
All right. So now the bottom layer. So we say that private GPT is a value added value, say SaaS product in a sense. Private AI Factory is a set of tools which enable us to enhance that. And private NeoCloud is our AI cloud, which is the underlying infrastructure. If we think in terms of classical architecture, then the underlying layer would be the data storage layer. We're partnered with NetApp and Vast Data for that, and there's different reasons we might use one or the other. They have each their very own unique characteristics. The middle layer you consider to be the network. That's a kind of Ethernet or InfiniBand specialized networking for high throughputs. And the top layer would be the GPU and also the CPU layer. Of course, there's also applications that still rely on traditional CPUs. So in this stack, you can see that you can start easy and then tweak, or you can kind of tweak it for what you need, or you can start with the infrastructure and build something yourself on top of that on our infrastructure.
Yes.
All right, now we did promise a little bit of insight. We find that in conversations, it gets a little confusing, all the NVIDIA platforms and the different types of GPUs. And so we decided to just put a simple chart up here, which gives some insight as to the platforms that we have deployed in our NeoCloud. So we have deployed all of these platforms, all of these GPUs, and we've learned quite a bit, and we wanted to share some of that. Arnold, do you want to take us through the RTX and OVX and the connectivity of that? I think that's an interesting note.
Yes, sure. So basically, we're used to talk about the GPUs, right? So the L4, the L40, that's what you see. Those numbers you see go around a lot. And even if you talk about the bigger GPUs, the H100 or the H200, those are GPUs that are can be deployed differently. So in basics, you will have four types of platforms: RTX, OVX, HGX, and DGX. Those are NVIDIA platforms. And those machines, basically, or those platforms, deliver different types of cards, and they have a different use case. So, for instance, the RTX delivers smaller L4 cards with only 24 gigabytes of RAM. They're connected through PCI. I'll dive into that later on. And their sweet spot is running efficient inference. And with inference, we mean the making the AI operational, so in day-to-day use. So every time you talk to a ChatGPT or Copilot or whatever AI tool at this moment, you're basically talking to its inference side. And running that inference is something that you need to do 24/7. You can't do it just a couple of hours a day. So you need efficient infrastructure to help you make sure those services run continuously without breaking the bank. That's where the RTX comes into place. The next one is the OVX. It's more used for high performance graphics and combining that with AI into digital twins. But the cards are also used for the somewhat larger inference runs. It's a real multi-use system or card. Both those cards are connected through PCIe, which is basically the card that you put into a server, the traditional method of putting GPU cards into a server. And it has some limitations in part as soon as you go to clustering those cards up into big clusters. That's where NVLink and InfiniBand come into play, and you see those that connectivity in the HGX and DGX platforms. So here you will have the bigger cards, the H200s. They will have a lot more RAM and a lot more GPU power, compute power, and they're mostly used for training, tuning, and running inference at scale. So if you are if you have a very large AI platform running or application running, it kind of makes sense to change inference from smaller GPUs to big GPUs. The big difference between PCI and NVLink InfiniBand is the ability to connect those GPUs into large clusters. What you hear about the thousands and 10,000s or even 100,000s of GPUs which are connected into a single cluster. NVLink and InfiniBand have a lot more performance than the PCIe models do. You can get H100 and H200 cards as a PCI model. We don't use those systems. We would like to take the benefit of the NVLink InfiniBand benefits and stay away from PCI at that point. So basically, that's the biggest difference between the four cards. And obviously, there's a price part that comes into play, and you need to really look at the different cards in your use case and see which one makes most sense for you to use.
And of course, with our experience, we're running one of the largest, if not the largest, NVIDIA infrastructure in the Netherlands. We have figured out the sweet spots of all these platforms and getting the best price performance. One practical thing we've learned, which is really interesting, is that of course the amount of memory per card limits, for example, what kind of open source model you can run on that card. So some models, the larger models, can only fit on the larger memory sizes like the 48 or the 141 gigabyte. And you can squeeze them down with something called quantization, which in a simplistic term is kind of like a compression of the data, which could impact the quality. So there's lots of engineering and software development being done to squeeze those models down into smaller and smaller cards to make it more affordable. And so we're on top of all those things and can advise how to get the best price performance for what you're actually looking for, rather than just overspending and hoping for the best. So real world experience is actually vital there currently.
Absolutely. And don't forget, right, so these systems that you now see, the platform systems, they're all 8-way systems, so they have 8 of those GPUs inside. And sometimes people are surprised by the fact that if you use one of the bigger Llama models like the 405, right, it needs actually a whole system with 8 GPUs to run, right? So the big
it needs
models,
like 800 or 900 gigabytes of memory, so you can't run that on a smaller card.
No, and then the NVLink really comes into play, right? So it really is the performance of the model, and then therefore the outcome of your investment.
So we're big proponents of the SuperPod reference architecture from NVIDIA. That generally on the HGX and the DGX means the NVLink. And where we see a lot of performance limitations on public cloud is that they're very often using the PCIe versions of these. And once you get beyond one card, you have a fundamental throughput bottleneck on the backplane. And so we think that the NVIDIA SuperPod reference architecture, our relationship with NVIDIA is very, very important there, because then we get all the knowledge for the InfiniBand, the file systems, and putting the whole thing together with them. And so we make sure that we can deliver the maximum value there. In fact, here's a question of what is the difference between the DGX and the HGX? We get this question a lot. We actually are running both platforms. We're an official, DGX and HGX cloud provider. Besides the fancy gold faceplate, which we often everybody loves, right? On the DGX, there's a few little differences. One is the DGX is produced by NVIDIA themselves, whereas the HGX is an OEM, original equipment manufacturer, is what OEM means. And that means that other companies have the right to build the identical system. So like Supermicro, could be HP, Dell, Gigabyte, et cetera. There's quite a few of these. And so with the DGX, you're interacting directly with NVIDIA. And I think for large enterprises, that's a really important characteristic. They like to, for the large scale systems, the 1,000 GPU systems, they really want that direct relationship. The DGX is pretty preset with its hardware configurations, and it automatically includes NVIDIA's AI enterprise software suite. So with NVIDIA DGX, you really get a full experience together with NVIDIA, with all their software capabilities. There's nothing missing. It's a little bit more expensive than the HGX, but I think for large enterprises deploying, they're really happy to pay that premium to get the best relationship, the best support, the best software capabilities. The HGX we see is a little bit more flexible, meaning it's, for example, also supporting more diverse workloads, multi-tenancy, if you have a very complicated environment, or sharing that cluster. And optionally, we can enable AI enterprise. So you still can get the same level of support, the same complete software experience, but it is optional, and it's a little bit more modular in its design. Did you have any further thoughts there, Arnold?
No. As you said, right, we run both models or both systems in our data center for our customers, and we basically see that they're in use. They're about the same. We see the same performance throughputs in the benchmarks. but they're different in their approach to the whole stack. So DGX is a full integrated stack with the software, the support, everything. You will get the new GPUs in the DGX first. The firmware and the driver updates are in the DGX first, and HGX will follow after the DGX lead. That's the biggest difference between the two.
Yeah, and that being said, before we move on, we were one of the first neoclouds to deploy the DGX H100 about a year and a half ago in our cloud, and happy to also announce here that we're also one of the very first in Europe to have already deployed our HGX H200 system. So those have been slightly delayed across Europe, and we're very happy to say we have a very large set of clusters that are available now for customers. We're burning them in now and getting ready to deploy those. The essential difference between the H100 and the H200 GPU is that the H200 has 141 gigabytes of memory versus the 80 or 94 gigabytes of memory from the previous model, H100. And that allows us to run much bigger models and extract a lot more performance. Also recently, I think we're very excited to announce a newer addition to our capabilities, and that's with our hands-on AI consultancy team. So, in the United States, you have a lot of AI companies, and in Europe, we have less AI companies, and we're more in the phase of AI adoption in traditional companies. And what we found is that, providing the AI factory or the private GPT or the cloud to the more classical types of European companies, they often get a little bit stuck with a skills gap. Some companies have started to hire these people and these specialists, others haven't. And so with our AI consultancy, we can get started immediately. We can assign our AI consultants to help understand the objectives, the project, and help to do the onboarding, the integration, and fill some simple gaps in terms of the software development, the interfacing, the security, all of these kinds of things. And we've already had tremendous success with that. It's helping our clients move a lot faster, which ultimately is the goal right now.
Absolutely, yeah.
So I think as we get, really appreciate everybody's attention here, and we wanted to keep it relatively short, so we'll get here towards the end. On your corporate or organizational private journey, we have these basic steps. We do suggest that you just start. Don't sit around too long, thinking about experiments and whatever. Just get going. We can help guide you with NVIDIA to the right low-hanging fruit and the right objectives. Just start with a private GPT. We can always improve it over time, right? But then you can take a small user set. You can start getting feedback, start iterating. The business adoption typically means, do we need to do some model training, some fine tuning, connect the data with a agentic RAG workflow, which is really the key to success. AI inside of corporations and nonprofit organizations just isn't going to be very successful without connecting the right data sets. All of these things have a relative cost, but when you get to the actual deployment of that in production, we could call that inference or runtime or production, then you really start to see the benefits. And so what we've learned is that don't take too long experimenting, just get into it and try to scale that. In our case, we also find that it's also nonprofit organizations that are actually really benefiting as well as for-profit corporations. We're currently working with an extremely large Netherlands cancer institute to develop multimodal, with a couple of partners to develop multimodal cancer solutions that improve patient care. We've been working with TU Delft and their team EPOC on some nonprofit projects like mapping the world's sea kelp bed, helping to identify malaria from simple blood samples so that people who are not near cities or can't afford to go to the hospital can get properly diagnosed. So we're also seeing that, there's a lot of skepticism about AI, but we're seeing that next to the capabilities of transforming organizations and the modern approach that organizations will be taking, that there's a lot of really, really good humanistic kind of projects that we're really happy to work on. So it's not always about profit. Sometimes it's about results and helping people. And that's one of the really interesting things we've learned, from being able to provide this advanced hardware configurations. So,
yes.
Wrapping it up, Arnold, maybe you want to wrap it up for us.
Yeah, so this is the statement I make in most talks I have about the transformational power of AI. I think that more and more people in business leadership realize that this is not an evolution, but it's a revolution, right?
Yeah.
If you want to wait until AI is fully adapted and fully a full product, then you're basically too late. People or organizations should act today because AI is already making the difference. And if you're able to tap into that journey and make sure that you learn along the way how AI works and how you can adopt it and tweak it and fine-tune it to make it better work for you, it will put you in a position that you can lead in front of the competition. And if you wait until AI is brought to you as a consumable service, it will also mean that you will be a generalist and somewhere in the pack, and it will really hit you in your ability to compete and to stand out from the competition. So forget tomorrow. AI is rewriting the rules of business today. And I think every business should have the ambition to take control. So AI is the way to go.
And with that, we'd like to, make ourselves available. We've got, as mentioned, all of the services, all the expertise. There's no reason to wait. And I would recommend, if you're thinking about deploying anything and would like to discuss it and get some good feedback and learn from our experience, please reach out to Arnold, reach out to myself, reach out to anyone in our organization. We're all ready to help. And if we can be of service, we'd be happy to. So with that, I would like to thank everybody for joining. We'll be posting, this will be posted again for reviewing on our LinkedIn site under events. And we look forward to next time. Thanks, Arnold. And thank you, everybody, for joining us today. Have a great day.
You too. Thanks, Ben. Thanks all.